Start streaming. I hope this is working. Yes, it is. Good day, folks. Here I am again, random live here. Hopefully I spelt that right. Interesting switching. Sometimes I type too fast. Yeah, that's fine. Before I get ahead of myself here. So, hello everyone. I hope everyone is doing well tonight. Just the regular random chat. No specific order, just regular chit chat. I'm just going to wait a few moments to see if a few people get on, and then I'll talk about some switching with the peg cells here to start, and we'll see where that takes us. And hello, everyone. I see it's working. So I hope everyone's having a good night. It's evening here. It is 7:28 p.m. here in Cochrane, Ontario, Canada. The weather is about 32 degrees Fahrenheit with a mix of icy rain and heavy winds. So looks like winter is well on its way, which is expected for this time of year up north here, considering we're on the 49th parallel, literally. So people do imagine that we live in igloos and things like that, so that's kind of hilarious. When I actually hear comments like that, I reply like, yes, and my laptop charger is plugged into one of the ice sockets, and they're like, really? Yeah, it's called ice energy. But you know, sometimes you got to joke a bit too, right? Because if you take everything too seriously. But no, we don't live in igloos. As you can see, it's a regular building like anywhere else. And it's not minus 40, as some people would think it would be this far up north. So, with that said, hello everyone again. I see people are interacting. So, somebody making a joke about my hair here. I have to say I don't have a lot of it. So, at least it gives my head a shine. But you know, can't really mask aging. It is what it is. I'm going to be 39 years old this winter. So, aging is not something I look forward to, but it's something we all go through, I guess. So, not going to go out of my way too much to try and hide it. It is what it is. But I'd like to get a few things done in my life before I get too old, while I still have a chance. It's good to have, you know, a semi-stable body to work on these experiments, especially with the heavy stuff. As you get older, it hurts to bend. It already does when I get out of bed in the middle of the night. So, anyhow, it is what it is. You found something interesting about switching last weekend. What's that? Just reading some of the comments here. And again, hello everyone. I don't know how long it takes for me when I read a comment. I think it's about a 20-second delay or something like that. And I hope my audio is doing okay. You made a video and posted it on YouTube. I'll have to check it out. Awesome. I like it when other people post videos about the switching concepts. It's nice to see other people experimenting as well. I'm older. Thank you. Oh my goodness. Maybe I shouldn't have said my age. Mm. Yeah, and believe it or not, I have my fair health issues with the tremor from Parkinson's and a few other things, but we deal with that on a daily basis. I control it. I exercise, nothing major, but you know, work on stability and that sort of thing. And it is what it is. But yeah, I mean, again, part of it is I don't like the idea of getting older, so um, sometimes I try and push myself just to go out there and take a walk. That's where the dog comes in, right? That's an excuse. Gotta walk the dog. Yeah, the magnets are great, and if you place them just right, you could really. The thing with relays is they usually take a bit of current, but if you place the magnets just right, you could use the energy of the magnet to partially get it there, if you know what I mean. So your trigger only has to be minimal. I'm sorry if it sounds like I'm going all over the place here. I'm just trying to answer some of the comments. So what I wanted to talk about, since there's some people here now, was, and of course people can go back and watch these videos later, is I have it disconnected, but I still want to show the basics here. So here's a capacitor bank. So I was running an oscillator off these capacitors, and these are some of the cells with the sodium metasilicate gel that hardens. But for now, back to the traditional peg cell, which has the unique properties of um, essentially working like a resistor, but because it has its own potential, it gives it that super high impedance we want, but it doesn't also bring the potential down like a normal resistor would at that incredible impedance. So it acts as a series DC circuit. So it actually contributes to the potential instead of taking it away and offering you that very high impedance. So just the one of my older but good working peg cells. So essentially I have all these transistors here, and I was testing the NPN one here, the 2N5088, which is a 30 volts 50 mA. So I was looking for something that was a very low power. And essentially as a basic Joule thief circuit, with one of these high frequency coils here. So I've got my 3 prompts right here. So it's actually 4 wires, but the 2 here twisted together. So I feed my power here, and I got the 2 positives or negatives on this side here. So typical, very simple Joule thief like setup. And what I did is, usually you have the base or the bias resistor, right? Now what I found out the other day is I was able to replace that with the peg cell. So what I'm getting at is a very efficient way of switching something traditional like a Joule thief. And I was still getting like over 14 volts on the output. So, you know what I'm getting at, instead of using current from the primary, you know, from the your input switching, like this, say it's connected to a basic battery, you still need to drive it with some base current. Well, we drop it very massively and use the potential. But the thing is, the peg cell on its own, which I've tried this, is not enough to drive the transistor. But when it's put in series with another DC source, it tops it off. So it actually reduces the input requirement to switch a very, very simple transistor Joule thief circuit. So I'm going to try and draw it here. I don't know if you're going to see that because people keep asking for circuit diagrams, but this is a very easy concept here, which you have your transformer here. I'm going to try and make this oversized so you can see it on the camera. So 3 prompts here with your center tap. So you can feed your plus here. This is how I do it, the plus of your input source over here. So on these 2 outputs, you have plus here and plus there. So this output here would go to your transistor. So let's say the transistor is here. This is the base. This is the emitter. This is the collector. So this would go to the base. You see, so instead of having your resistor here, we put the peg cell. See, I drew it too fast. So we'll put the peg cell right here. We'll put a break here and say that's the peg cell in series with one of the coils output. So negative, positive here. which goes and feeds into the base. So then you have in your collector the other plus, and then the negative. This is if it would be NPN. So negative right here, and we're assuming um, NPN. So I don't know if you can see that on the camera here, but just a very simple joule thief circuit. But instead of a base resistor, you replace it with the peg cell, and you get the same switching for a fraction of the typical power you'd get, and you end up with the same potential, essentially what you want, that pure potential zero current to work with. So I had realized that the peg cell did very good for even simple concepts. You know, it doesn't have to be very complicated like some of the circuits I've been showcasing lately. That's what ultimately you'd want to do to get more efficiency. But someone could take something very simple like a joule thief circuit and make it more efficient with the peg cell as is without having to do anything more. Because even though if it may not necessarily be over unity in a sense, but if you can make an existing system 75% more efficient just by doing that to it, it's that much more power to you. So if you're running like a solid state Tesla coil or something like that that operates in a similar fashion, there's another way to feed it, you know. Just ideas out there. You know, this is not the thing that would get you over unity. That's not what I'm trying to say. It's just I found out in this very simple configuration, very simple, that there's quite a good gain by just doing it that way. But of course, one would have to do something more, right? But it's a start for someone who just wants to experiment with it, you see? So I'm just going to go here and read the comments here. Hello, everyone. Hello, everyone. Just reading. Can't see what you are drawing. Okay, so I'll try and bring the drawing closer here. And essentially what I was saying, I don't know if you can see that now. It's weird, it's not showing up. Bad color, that's weird. The camera's not, I put it in highlighter green, but it's not showing up. That's weird. Uh, it's just a joule thief, simple joule thief. But instead of a base resistor, you put the peg cell in there. That's all it is. So literally a transistor, a coil, and a battery and a peg cell. In the most simplest form to experiment with some of the effects. But I will find another marker for next time though, because I don't like that. It's weird that the camera isn't, it's really bright for my eyes. I see it fine. I use this marker here, but this green tint, for some reason, the camera isn't catching it. It's like got a filter or something. So my apologies for that. I will use another marker next time. I thought I was smart there being able to draw it. That backfired. I tried. Yes, I have experimented with a magnetic field and the peg cells. Results varied depending on the configurations. Um, at some point, I noticed a gain while I was aligning one of the peg cells, you know, when it was still in a non-solid form, when the peg was still warm and solidifying, and I had the magnet as it was settled. I noticed quite an increase during that time. But just putting a magnet randomly next to a peg cell like that, no, I haven't seen any difference. But during that one time, I have it. I think it's called crystal cell keeps charging up. I had a magnet right next to it. That was a little interesting. But it was literally only that time that I noticed something. And some argued that it may not have anything to do with the magnets, so I don't know. Don't want to push something that I'm unsure of, but I do make videos of anomalies and, leave it up to everyone else to say what they think it could be, right? Yeah, there's a lot of possibilities with the peg cells, and what I like the most is their ability to act like a resistor but contribute to the potential. So in a sense, it's kind of like a negative resistor that gives you impedance but brings up the potential. You see what I'm saying? So when you start putting that in line with your traditional circuits, you change the whole dynamics. You introduce that extreme non-linearity in the circuit, in Tom Bearden terms. Some of the requirements we need. Yeah, spinning something in it would be an idea. Speaking of spinning something, there's something that I keep wanting to work on and I never finish. It's a motor, which is a generator and custom built. And I used a hard drive motor, three-phase, and eventually I'd like to run a Drone ECS controller to drive it with, because this is very easy. I can blow on it, and even under a load, I got a three-phase rectifier on there. And what I like to do is build a Arduino switch for it that would pulse the three-phase signals coming out of the ECS controller so that I can switch it on and off, because I've realized that for a long time, even when I do it by hand and I connect an LED on here, it stays lit up for a long time. So by offering the asymmetrical regauging, by breaking the three-phase signals in specific sequences that I like to experiment with, I might generate some interesting outputs with this, similar to what Jaal Morin was doing with his washing machine motor. So, in a smaller scale, anyways. And, yeah, one day I'd like to get this going. So yeah, I see people, yeah, there's a lot of possibilities, and no, I haven't tried most of them. I've tried a lot of them, but not most of them. A lot of chemicals I'd like to get into, but it's getting access to, at least with the bismuth titanate and things like that, it's not as toxic as barium ferrite. It'd be still a bit of a cost, but it's easier to import and work with. So something there to explore, and also various redox reactions. So we can work with more traditional electrodes and stop the corrosion factor. So a little bit of insights in my last video on how to do that, which happens to be compatible with the sodium metasilicate material. But I'm getting wild in my mind here and thinking of making hybrids and start mixing a little bit of PEG in there, and I don't know. I don't want to lose sleep over it, but you start thinking of all of the what ifs. So yeah, graphene, anything that's non-linear is good for capacitors. Um, that's why they build supercapacitors, some of them with the barium titanate. They very compressed plates. It has to be machined, very specific. So it's only semiconductor companies that have access to that because it's quite a strict requirements to get the barium titanate to do what it has to do. But essentially, any nonlinear is very good for dielectric. Faraday Research LLC. You mean what he does to um, the materials to stop the oxidization? I think that's what you mean. Yeah, I talked a little bit about that actually in my last video and offer some insights on how to build basically more traditional cells with that idea in mind. For those who don't have access, because I've noticed a lot of people around the world, the PEG is something easy to get in Canada at the pharmacy, but a lot of places, for some reason, they won't even import it from Amazon. So, these people can't even experiment with the PEG, but with the sodium beta silicate, some people argue, like I've had it here so far, no corrosion, but some people argue that this is basically a variant of a galvanic traditional cell, which means eventually it would corrode. I don't see how it could because, it's hard in solution. But if it would, um, just figuring out some redox reaction, and there's a few chemicals actually, quite natural elements that you put in there and you mix it with, and it actually does a chemical reaction. It stops any corrosion, oxidization effects. It actually reverses the process altogether. So it could be useful for even water cells if people are into that. Mix it with that. You'll get a higher current out of it, that's for sure. Messy because water flies all over the place, but if you can slow down the oxidization, why not, right? I mean, yeah, barium titanate, that's it, right? They say it's toxic to the touch and to the breathing. So and even though it's an interesting candidate, not the best for amateur experimenters to get into. So that's why I recommend the other thing, the bismuth titanate, much safer, and even has extra benefits, especially if you're into the anti-gravity stuff, you know, much more potential in using that. Because a lot of thing is with the anti-gravity, and that's what hinted at my new Maxwell insights from the solved equations is for anti-gravity, we already know, a lot of us that are into it, that part of the equation is you need to have a non-symmetrical plates, electrical plates. So one side of the capacitor is non-symmetrical to the other to break that symmetry. But there's something more to the equation that people hardly ever talk about, which I believe the ones that are successful are not talking about. And this is what the new equations suggest is you also need to have a nonlinear a nonlinear dielectric material, which means is it's not enough to just have the plates being asymmetrical, but the dielectric needs to be nonlinear in a fashion where it can literally concentrate the field in a certain physical area versus another part of the capacitor. So when you have those two conditions, then there is possibilities for anti-gravity interactions. That's part of what the new Maxwell equations are hinting at anyways. So a lot of people talk about the first part, right, which is non-symmetrical electrical plates, but they hardly ever mention that you need a highly nonlinear dielectric that'll physically hold the charge or direct it concentrated in one area of the capacitor, of the dielectric. and keep it away from another. Yeah, maybe you can use the PEG cell. A lot of people are thinking that could just very well be the material to offer that nonlinear dielectric. But you need advanced equipment to be able to actually plot the field of the dielectric to see if it's concentrating or being tunneled in a unique path where it's grouping rather than being equal across the plate. So it's highly nonlinear materials, even a little bit of quantum tunneling that would do that kind of effect. So probably special materials would be needed. Maybe special core-like materials with multiple, where one end of it has something more concentrated of versus another end of it, and it's flattened out into an even plate, and that's your dielectric. But it, it it's different depending on its physical coordinate. So yeah, basically that's what I wanted to talk about, and more possibilities of the peg cell. The more you get into it, it seems like there's more possibilities, and I keep saying it seems to be better as a novel semiconductor than trying to use it to power stuff on its own, even though it'll do that to a certain extent. And with that said, I'm still powering my little clock. I'll show you. See, isn't it cute? Actually, I can probably show it. I don't know which camera I would, but there it is. I don't know if you can see that from there. Time is wrong on there because I don't bother programming the time. Can you see that? Just trying to get a good focus on it. But this is one of the flat cells that's like 6 months old. No problem. No problem. I keep it in my room, in my bedroom, as kind of like a novelty reminder. I look at it and, just a reminder that you can find energy anywhere in the universe if you look hard enough and you know how to take advantage of it, right? And it doesn't need to cause pollution either. Yeah, 6 months hasn't stopped. I had a bigger pile at a point. That's one of the cells of the bigger pile I had. I had it up to 14 volts at some point. And because they were flat, they were putting out more current. And I was charging a car 12-volt battery with it. But because, I lacked the ability and the equipment to make a perfect mold for it, holding it together with elastics, I couldn't keep it in place. And the symmetry of series cells, if one starts losing contact a little bit, it affects the whole pile. So I just couldn't keep it stable enough to really do something with it. But if I could, it would have been interesting. It supports my philosophy that if you actually want current, just keep piling them up like a Zamboni pile. And as long as every cell is symmetrical, as I was saying to some people in comments, okay, 10 milliamps at 2 volts is not very much, but 10 milliamps at 14 volts is a little bit more. Then you keep going, then 10 milliamps at 140 volts is even more. Then that 10 milliamps, as long as your cells are symmetrical, right? There's no real limit to how far you can go. And you can get to 1,000 volts, 10 milliamps. Then that's really significant, right? So it's just a matter of keep, but the problem is the more you have in your pile, the more difficult it gets to keep the effect going because any minor, the more of a chance that one of the cells will fail, right? And then it affects the whole pile. So when you're up to 1,000 volts, good luck finding the one that's failing, right? So there is an actual practical limit, right? That you could actually, in theory, you can go 1,000 volts, but unless you do it professionally, I don't think one can fluke it just playing Jenga with it. And John Hutchinson had exactly that same problem. He referred to it as a cell resonance, but basically it's just typical DC series cells configurations where you can have 10 batteries in series and the current is going to be limited by the one that puts out the less in the whole series, right? So if one of your peg cells is partially defected or not making a good contact, if you've got 1,000 volt pile, it's going to bring it all down, right? Then you have to find if it took you 1,000 peg cells, right, to get 1,000 volts, you're going to be there for a week trying to find out which one of them is the bad one, right? But just a few of them in the pile is not so hard to maintain, really. Yeah, it's just to build the proper housing where they're solid, they don't move, they don't short out. Someone could probably 3D print different sizes and build different potential cells. I would be happy if I could build like a 140 volt version, because then I could do maybe something interesting with that. I'd like 1,000 volt to get a spark gap natively, but it would be so hard, to get the cell alignment up to 1,000 volts. But if one could pull it off, that would literally be a continuous source of energy. You could charge 12-volt batteries with it. 1,000 volt spark gap cap dump continuously. That's a lot of current continuously hitting that 12-volt battery. How did I get the idea for the original peg cell? Trial and error. I was in my kitchen. I had my cell phone. I opened up my cupboard where I keep, my juice mixes and my spices and all of that. And I was really bored one night and I logged into ChatGPT and I asked ChatGPT, literally started reading ingredients off any random bottle. Can I use this as a solid state electrolyte? And I literally started with salt because I wanted to see what it would tell me. So literally all my spices, all my Kool-Aid, whatever chemical was in there, I would ask ChatGPT, how can I turn this into a solid state electrolyte? It would flat out tell me if it, don't think about it, this won't work. Then my roommate, had this peg stuff because sometimes, he's not here no more, but he had problems going to the washroom. It's a lactative. So I found that next to the Kool-Aid powder. So I'm looking at that, poly, that 3,3. So then I asked ChatGPT, can I use this as a solid state electrolyte? All of a sudden, PEG is an excellent choice and blah, blah, blah. And it's also known to have electret properties at room temperature. And it's just going on and on. And I'm going, oh my goodness, did I just find gold here? So I rush, to mix it up and see if I can make a cell with it. And sure enough, I got astonished right away with the results. But sometimes that's what science is. You have an idea, it was rudimentary, but it was a solid idea. I wanted a solid state electrolyte that wasn't the crystal stuff that John was playing with. So I knew what I was going for, but I didn't know exactly. So, like I said, I was a good find, a really great find. Yeah, of course, but I have to say, ChatGPT was a lot more cooperative with the stuff in the beginning. It got really dense, and but with the Tom Bearden, I trained a new one based with the custom GPT. It's available for everyone. It basically jailbreaks it, and it works as good as it ever did. So as long as you run the Tom Bearden GPT model, it cooperates and gives you all those suggestions without telling you that, it's non-traditional, don't bother with it. But if you use the normal chat GPT, it just lectures you on, mainstream science says you shouldn't do this, essentially. So that's why I did the Tom Bearden one. I'm surprised they kept it up this long, because I was sure because it goes against their regular model behaviors that they would nuke it eventually, because it's got like a lot of people are using it because you can see how many conversations people had and they're rating it. It's got really great ratings. So even high profile people on social media, the influencers, some of them have mentioned it, the Tom Bearden GPT. Without mentioning my name, of course, because they won't do me a favor to try and promote me, obviously. But they had no problem saying, "Holy moly, somebody actually did a Tom Bearden Chat GPT, and it's so incredibly, accurate." I guess all I could say is thank you. Somebody did, had to. Uh, the link to Tom Bearden GPT, hold on. I use it every day, and I have it in a video to show everyone where to go, but the video is already like 6 months old, so I guess not everybody knows about it. So I will just give you the link right now. You could also search for it on ChatGPT, Tom Bearden. But there it is. This one here, you can have any conversation about everything we talk about. From it even knows, because I fed it all of the data from the PEG cells and Tom Bearden, so it knows all about asymmetrical regauging. You can feed in one of your circuit diagrams. It'll describe it and give you ideas and how to potentially use it to tap into the 0 point based on Tom Bearden's suggestions. It does all that without nagging. Yes, Tesla stuff, Tom Bearden stuff, Bedini stuff, um, Floyd stuff, um, a lot of my stuff as well. And it takes all that and build a persona out of the information and responds based on that information. So like I said, it has to be good because people are giving it great ratings. So yeah, well, if you feed it certain things, right, you can get it to cooperate sometimes to some extent. But if they don't like what you're feeding, they usually have like it catches on and always tries to revert the conversation back the other way. I noticed it did that a lot with politics. Without getting into the details, it favored one philosophy over the other and made it sound like the other didn't exist. I thought that was super unfair personally, and it did trigger major controversy, but that's just an example on you can even insist and give it common sense information, and then it doubles down on the not so common sense answer, let's just say. But yeah, I think they all got called out on that pretty good, and I think we all know. Yes, it does say by Joel Legacy. Yeah, exactly. It gets like dumb again the next day. It's like it doesn't remember your conversation. So hopefully the Tom Bearden GPT helps with that because it always has that information. So it's got like I gave it the prompt, the custom prompt in the beginning, telling it that it's Tom Bearden and it's act like Tom Bearden. It takes the role of Tom Bearden. So it's ready for that question, whatever it is you're gonna and you're going to ask it, right? But I put all of that in there. I gave it the customized prompt to make it think it's someone like Tom Bearden that's super interested in alternative energy systems. So if you want to chat with it, it'll just go on and on all night. It's programmed to love and want to keep elaborating and speculating on new ideas to try based on the information you feed it with. Yeah, it's okay. Well, I guess they spelled it wrong. As long as I didn't spell it wrong, it's okay, right? But sometimes it's text to speech, right? We do a lot of that, and or vice versa, talking, and it doesn't translate well. Sometimes, especially when you're trying to tell your phone or your Alexa something, it never understands right. Yeah, I'm surprised you folks didn't know about the Tom Bearden Chat GPT. I was talking, I guess I started drifting in other topics, but for like a few weeks, that's all I talked about at every video. If you want more information about this concept, visit the Tom Bearden GPT and he'll help you out. It's been a valuable tool for a lot of my research, anyways. Helped me a lot. Like sometimes I have an idea, right? Like I'll draw a circuit diagram of something I want, but I don't have the words to, describe it from the beginning and what it does and what it can do. So I give it the image and here's my circuit. Can you give me a nice description in the Tom Bearden philosophy and terms? Then it gives me that. So then I could put that in my form with the circuit diagram so people have a nice summary in English and proper wording that actually explains it better than I could, right? Like I came up with the circuit, but sometimes I don't have, I'm not a composer. I don't write poems and songs. So sometimes I don't have the words. I miss the meanings and the points. Well, it can do all that for me so that the circuit, you know, shines for the way it should, so everyone can understand the benefit and what it means, right? So with that said, folks, I think I will wrap it up for tonight. I just wanted to come on and say hello and offer that very simple joule thief switching mechanism with the peg cell without modifying anything too drastically, Again, it's a very basic system. I never promise over unity with it, but you should get a much greater efficiency by doing it that way using the peg cell instead of the base resistor. So, with that said, folks, I hope you have a wonderful evening and thank you all again for your support. And thanks for watching and share these videos to everyone who you would think would be interested in this stuff. It really helps, promote the cause and get other people like me and you to experiment with these concepts as well. And that's how it develops and gets further enhanced. So with that said, folks, have yourselves all a great night and thank you again.